Yeah, welcome guys. So please type in the chat box. Is the audio and video clear to you? Every one of you. So please type in the chat box. Is the audio and video clear to all of you? Every one of you. Please type in the chat box. Yeah, welcome all of you. So please type in the chat box. Is the audio and video clear? Not coming. A minute. Let me. Yeah. Good evening, 𝐂𝐚𝐿. Please confirm the audio and video once. Is the audio and video clear to all of you or not? It's clear, right? Yeah, thank God. Fine. So let's start the session basically. So we'll continue our next lecture in this 7 p.m. series. Okay. So of course we have started single variable calculus and we have finished a couple of lectures. Okay, in the last and the preceding classes. And in today's class, today we are going to look at lecture number 3 of the same module, single variable calculus again. Okay. So if you briefly go, we are discussing the concepts of limits and derivatives. Of course, now we will actually move a bit into this applications of differentiation. Okay, like the mean value theorems, concepts of maxima and minima, generation of the Taylor series. Okay, so in today's class, the major focus will be like applications of differentiation. Okay, but anyway, before that, we'll again look at some standard limits and the ways in which we can apply the derivatives. Okay, so but before going, this is basically the codes for the updates on this channel. Okay, so this is the Telegram channel link for the Wallah English channel. So any update on this channel would be posted here. So I recommend you to scan this and follow the group actually. Okay, and this is my personal group, of course. So here you can see a lot of any update from me would be coming up on this channel actually. Okay, and like if I'm again planning to post some practice sheet of basically linear algebra and also single variable calculus. So these things we are going to post at this particular location. Okay, and Unity Future is what we have recently launched. So if you just type Unity PW and if you just join that, then ultimately you can have a track record of all your points. The only thing you have to do is basically if you're asking a doubt, then you can click exclamation doubt and then you can start your doubt. Similarly, if you want to make a notes at one point, you can type exclamation note and then keep the point. Then ultimately these get stored in a space. Okay, so Unity space. So again, I recommend you to sign in for this Unity space. It's absolutely free, and once you sign in, you'll have a record of all your interaction during the live classes. Okay, at one particular place. Now coming to the last lecture. In the last lecture, we were mainly focusing on some nice standard graphs. Some standard graphs is what we have plotted. Okay, and we have also seen some standard derivatives. Some standard derivatives. Okay, so standard derivatives, and you can also see apart from that, we have also seen calculation of some limits. Okay, so calculation of limits is what we have seen, of course. Okay, so calculation of limits. So these are the things that we have discussed in a brief things. Okay, yes sir, we want question. Yeah, that's what. Okay, I'll upload a practice sheet hopefully by Sunday. Sorry, not Sunday, by hopefully Monday evening or things like that, so that you can have a practice. Okay, so kal class hogi. Yeah, I'm just coming up to the things. So how to balance gate and semester? Yeah, I'll tell you. Okay, this is one of the most frequent question that people ask me. How to manage your college time with your gate preparation? Of course, I'll do tell you. Okay, and in regarding tomorrow, the block matrix and its properties. Yeah, thanks 7. I'll basically discuss this. Okay, properties and also block matrix and of course the Cayley-Hamilton theorem. Yeah, okay, I'll discuss. And coming to class on tomorrow, Ashwini, basically we have a doubt solving session tomorrow. Okay, so at 7 p.m. on the same channel, of course, we have a doubt solving, and not only doubt solving, if you have any queries. Okay, like few days back we have conducted one on our Telegram channel. So something similar, if you have any doubts or if you have any queries regarding anything, you can just come up at 7 p.m. tomorrow and we will discuss the thing. Clear? Now let's see. Apart from this, I have given you some homework. Okay, so let's firstly quickly answer this homework, and then we'll deal this Cayley-Hamilton theorem and block matrices, of course, a bit, and then we'll go for today's topic in general. Okay, so I have given you this question: limit x tends to 0, e power 2x minus 1 by sine 4x is equal to dash. Okay, so this integer type, and if you have solved, please enter the answer in 30 seconds. If you have solved, definitely you can enter the answer. So if you check this, then this value of the limit is what? Okay, that's all. Come on, do this. Also tell us how to manage time for GATE preparation with job. Yeah, definitely. Okay, maybe in the last 20 minutes of today's session, please, or basically can we discuss these two things in tomorrow's class? It's better, right? Because tomorrow is like a generic session, and of course you can ask your doubts very well. I have some Telegram queries which came in my Telegram channel for a few days. I'll answer them, and also we'll answer a few other things. Okay, so anyway, the poll got finished. So let's see how do we calculate this. Okay, so solution, limit x tends to 0, e power 2x minus 1 by sine 4x. This is what you got. Okay, so ultimately if you simplify this, you can get a 0 by 0 form. Okay, because you know, if you put x equal to 0, this is e power 0, so 1 minus 1 gives you 0, divided by sine 0 is also 0. So this can be written as, by applying L'Hospital rule, you can say by L'Hospital rule, by L'Hospital rule, limit x tends to 0, e power 2x minus 1 by sine 4x is equal to, you know, you can actually differentiate the function, so functions individually. So limit x tends to 0, what would be the derivative of e power 2x actually? Okay, so the derivative of e power 2x is 2 times e power 2x, derivative of 1 is 0, divided by the derivative of sine 4x is nothing but 4 times cos 4x. Okay, so this is what you'll get. Now if you replace x is equal to 0, then ultimately this is 2 into e power 0 is 1, divided by 4 into cos 0 is again 1. This can cancel this 2 times, so you have 1 by 2, which is equal to 0.5. okay, so therefore limit x tends to 0, e power 2x minus 1 divided by sine 4x, which is equal to 1 by 2, of course, and this is 0.5. Okay, a simple L'Hospital rule is what you have to apply in order to solve this question, and I hope many of you might have solved this, because it's a very simple question based on simple logic that we have yesterday. Okay, then look, let's go to the next question. So anyway, 0.5 is the answer. Let's see if some of you have entered 0.5. show results. Yeah, okay, 100%. One student answered correctly, but who is it? Come on. Okay, the box is not giving the name. Okay, fine, but still we can find. If you go to leaderboard, 𝐂𝐤𝐵𝐾 is the one who answered. Okay, so 𝐂𝐤𝐵𝐾. Good. Hello. Let's go to the next question quickly. So this is one more question I've given you. The value of limit x tends to 0 minus sin x divided by 2 sin x plus x cos x is what I've given you. Okay, so again integer type. So 30 seconds. If you have solved, please enter the answer. You can enter it in decimals, whatever. See, if you have negative answer, just enter the positive value. Okay, because here there is no provision for entering negative. So if let's say your answer is minus 0.25 for example, okay, then enter 0.25. okay, Ashwini, it's not 0.55, it's exactly 0.5. okay, yeah, good. Come on, answer this quickly. 0.33 is what it's coming, maybe. Let's check it up. Okay, so let's see. Okay, maybe 0.33, I don't know. Let's solve and get to know. Solution, limit x tends to 0 minus sin x by 2 sin x plus x cos x. Okay, so plus x cos x. This is what you have. Now one thing that ultimately comes here is, if you keep applying the L'Hospital rule, it becomes a slightly lengthy problem. Okay, so first problem I have given you using L'Hospital rule. Of course you can directly get the answer. Here if you try to apply the L'Hospital rule, of course the thing slightly gets elaborated. Like, I'll tell you two methods to solve this question. So method 1 is what I'll just tell you maybe quickly. Method 1, and we'll also see the method 2. Okay, so method 1, the classical L'Hospital rule will apply, and let's see, because this ultimately gives you 0 by 0 form. Okay, because if you put x equal to 0, sin 0 is 0, then 2 into 0 plus 0 into 1 is again 0. So that's how we have. So limit x tends to 0 minus derivative of sin x is cos x by L'Hospital is what I'm writing, by L'Hospital rule, by L'Hospital rule. Let's see here. So limit x tends to 0, limit x tends to 0 minus derivative of sin x is cos x divided by then 2 into derivative of sin is cos x plus derivative of x into cos x into minus sin x plus cos x. This is what you'll get actually here. Okay, so this is what you'll get, and ultimately if you put x equal to 0 in this case, we'll get minus cos 0 1 divided by 2 into cos 0 1 plus 0 into minus sin 0 plus cos 0 is 1, which is minus 1 by 3, of course. Okay, so minus 1 by 3, which means this value is minus 0.33. let's say if you round off to 2 decimal places, so minus 0.33 is what you have as the answer, of course. Okay, so minus 1/3, which is minus 0.33, of course. Okay, now the second method which I would like to do is, few times just because of adjusting the terms, you'll get the answer very easily. See, you know, limit x tends to 0 minus, okay, this minus I am pulling out for some time, sin x by sin x, no, 2 times of sin x plus x into cos x, x into cos x. This is what you have. Okay, now let's observe something. Can I do a division with x all over? Okay, so if I do a division with x all over, this can be written as minus limit x tends to 0 sin x by x, because ultimately when x is tending to 0, what does this total function tells you? That means individually when x is tending to 0, individually these functions will tend to some particular values, and simplification of that. Okay, so 2 is constant again, limit x tends to 0 sin x by x plus, then you know this x and x can be cancelled, then limit x tends to 0 cos x. Okay, so this is what you have. Now ultimately, you know, if you just multiply this with x all over, then you can understand this limit value in the numerator is 1. Okay, limit x tends to 0 sin x by x is 1. Similarly, this value is also 1, and this value is also 1, because if you put 0, cos 0 is 1. So this is minus 1 by 2 into 1 plus 1, and this value is same as this value. Okay, so ultimately it is minus 1/3, which is minus 0.33. That's it. Okay, so by using some standard results, you can sometimes just fit in some x maybe in the denominators, numerators, and you can convert the limits into some known functions. Okay, is this clear to all of you? Yes or no? This minus 1 by 3, is this clear to all of you or not? Okay, Ajay, Prabhat, Sagnika, Ashwini, Premaraj, Chanda, 7, every one of you. Okay, now let's see. So let's check the correct answer. Since I have asked you to enter this only with the positive value, why it's not showing your leaderboard? Fine then. Okay, so good. Hello. Let's move next to the next question, of course. So in this question, I have given you again. So I have given you some options as well. So single choice, 30 seconds. Start. The value of limit x tends to infinity 1 plus x square into e power minus x. Come on, do this. Limit x tends to infinity 1 plus x square into e power minus x. Limit, it is another indeterminate form. Okay, it's like infinity into 0, things like that. Okay, so quick, done. So let's see if you try to solve this. And again, it's a simple question. Limit x tends to infinity 1 plus x square into e power minus x. Okay, so and ultimately this gives you the form something like infinity times 0 form. Okay, so in last class I have told you, when you're getting infinity into 0 form, but you know the technique only for infinity by infinity or 0 by 0, by using some fractions we can convert this into either infinity by infinity or 0 by 0. Okay, so if you make this slight simplification, like or slight adjustment, 1 plus x square divided by e power x, and ultimately when x is very large, both these functions tend to infinities, and so therefore limit x tends to infinity by L'Hospital rule, you can apply x tends to infinity 1 plus x square. So derivative of 1 plus x square is 2x by e power x. This is also giving you again infinity by infinity. So this is equal to limit x tends to infinity 2 divided by differentiation of e power x is again e power x. So this value is 0, of course. Okay. Okay, so therefore limit x tends to infinity, 1 plus x square times e power minus x is equal to 0. Okay, you can actually understand this function if you slightly look at the mathematical reasoning of this. The reason why this function die down to 0 as at a very large x, why this function goes to 0 is because, see, it is product of two functions. One thing is very clear, it's product of two functions, 1 plus x square and e power minus x. Now when x is increasing compared to the rate of change, okay, means for example if you check when x is increasing, 1 plus x square keeps increasing and e power x keeps decreasing, but e power minus x keeps decreasing, but the rate at which e power minus x decreases will be very fast compared to the increase in 1 plus x square. Okay, means let's say at a particular value of x, the product is some value, this product is actually some number, okay, so let's say L, then if you slightly increase x, the increase in 1 plus x square will be very much less as compared to the decrease in e power minus x. Okay, so when you keep multiplying, ultimately this e power minus x is the strong function out of these two, and this e power minus x will try to bring down this 1 plus x square drastically down, and within some limit it will go to 0. Understood? Did you understand graphically what's happening in the background? Of course, doing limits and all, it's fine, but because when I started this question, when I wrote this, I know the answer is going to be 0, because I know mathematically in the background it happens is e power minus x is very fast decaying function, so that will pull down this 1 plus x square very effectively. Okay, if you see the graph, you will see, even maybe I'll show you the graph actually. Oh, sorry. So maybe I'll plot this and show you 1 plus x square into e power minus x. Okay, so let's see, 1 plus x square, 1 plus x square into e power minus x. Okay, so you can see 1 plus x square into e power minus x. If you take this function, then ultimately this function has got some shape, of course, but after you reach this point, it dies down to 0. You can see when x is increasing, clearly, and x goes very large, then ultimately this function die downs, because the reason is once it crosses 1, the decay in the e power minus x is very fast, okay, as compared to 1 plus x square. Clear? So anyway, so the answer is going to be 0. Option A is the correct answer. Let's check it. A, none of you have answered. Okay, fine. So let's go to one next question. I have given you one more question. Yeah, this is a nice question again. So if you have solved, then enter the answer. 30 seconds. Again, I'm giving you the limiting value of the ratio of square of the sum of n natural numbers to the n times the square of the sum of squares of n natural numbers as n approaches infinity is dash. So how do you know that e power minus x is dominant function out of the two functions? Because I know exponential decay is very fast as compared to the quadratic increase or quadratic decrease. Okay, exponentially decaying you might have seen, okay, very drastic decays within a very short span, things die down or things climb up very fast. Okay, especially if you're doing in vibrating strings or in vibrations, you'll come to know. Okay, whenever there's a wave which you start initially, this wave immediately dies down when there is some overdamped oscillation or something. Okay, so obviously exponential functions are very fast decaying functions. So what we're talking, yeah, this question will solve. Solution: the limiting value of the ratio of square of sum of n natural numbers. Okay, so first of all, what is sum of n natural numbers? I equal to 1 to n. So sigma I, if you take sum of n natural numbers, this becomes 1 plus 2 and so on n. You know, this is n into n plus 1 by 2, of course. Okay, so n into n plus 1 by 2. Then summation, then sum of squares of n natural numbers. Okay, so sigma I equal to 1 to n. I square is 1 square plus 2 square and so on plus n square, n into n plus 1 into 2n plus 1 by 6. Correct? You know, these are the two things that you should know in order to calculate this. Okay, so sum of the first n natural numbers is n into n plus 1 by 2, and sum of squares of first n natural numbers is basically n into n plus 1 plus 2n plus 1 by 6. Okay, clear to all of you? Okay, so please type in the chat box. Is this clear? Do you know these things? Yes or no? Everyone, please type in the chat box. Are you, are you aware of these two things? Actually, if you know about those things, then things is, that solving this question is very easy, of course. Okay, yeah. So let's see what we have written. They have been asking you for when n tends to infinity, okay, because they told as n approaches infinity. So for very large n, let's see what happens. Okay, so for very large n, this value is, so the value of ratio of square of sum of the n natural numbers. So this is sum of n natural numbers, so square of this, limit n tends to infinity, n into n plus 1 by 2 whole square. Okay, so this is square of sum of the n natural numbers, this guy divided with n times the sum of squares of n natural numbers. So n times sum of squares of n natural numbers is this guy, so n times of n into n plus 1 into 2n plus 1 divided by 6 is what you have. So you have to simplify this limit, that's it. Okay, so if you simplify this limit, let's see what you have. Limit n tends to infinity, then you know it's a fraction, so you can simplify this, n square into n plus 1 whole square by 4, and you can flip this, because if you are multiplying this, 6 by n square, because n into n gives n square, n plus 1 into 2n plus 1, of course. Okay, so this is what you have. Now ultimately you can cancel this n square, this gives you 2 and this gives you 3. So 3 by 2 times of limit n tends to infinity. If you expand this, for example, no need of even expansion, you know, if you expand this, the highest order, the highest degree term would be n square. Okay, so n square plus 2n plus 1 divided by, and if you expand this, for example, 2n square plus 2n plus n, 3n plus 1, this is how you have. Okay, now what would be the value of this limit? That's the main you know, interesting thing that you have to figure out. Now in last class I have given you one technique. Okay, so when this n is tending to infinity, and if powers or degrees of this both polynomials is same, then ultimately ratio of the coefficients of leading degree is the answer. Okay, you know, this has the coefficient 1 and this has the coefficient 2, so ultimately this limit is going to be 1 divided by 2. That's what, correct? In last class we have seen, of course. So this value is 3 by 2 into 1 by 2, which is 3 by 4, of course, and this is 0.75. Clear? So 0.75 is the actual correct answer in this. 0.75. Fine. So please type in the chat box, is this clear to all of you? 0.75 is the correct answer in this case. Okay, yeah, so let's see. 0.75, if someone has entered this, 0.75. okay, this is not showing, but let's check here. Okay, again questions are Sagnika, good. So only looks like Sagnika is doing homework. What about others? You guys don't want to do? Okay, I'm not doing it just for fun. Okay, so when I teach something, when you try to answer a few questions, you'll get some doubts. Okay, and that's how the concept clarity actually builds up. Clear? So anyway, please spend time on solving the homeworks. So anyway, now coming to today's class, we'll put our focus, of course, a bit on limits. I'll have a few more points on limits and continuity. Okay, and we have mean value theorems. Then Taylor series is what we'll discuss, and if time permits, I'm not sure whether we can delete it today's class. If not, we'll delete it in the next class. So concept of maxima and minima is also what we'll try to focus on. Okay, now let's see, before we go for this mean value theorems, because I have a few things to talk in linear algebra. So first thing that I would like to tell is Cayley-Hamilton theorem. Hamilton theorem. Okay, so which is again in syllabus of very few people, and of course the application or number of questions which are coming on Cayley-Hamilton theorem is also very less. So basically this theorem tells you that every matrix, every square matrix in general, of course, every square matrix satisfies its own characteristic equation, satisfies its own characteristic equation, of course. Okay, so every square matrix satisfies its own characteristic equation. Like you can see example, I'll work out with an example so that you can understand it better. If you have a matrix like, let's say 1 2 3 minus 1, let's say for example. Okay, so 1 2 3 minus 1. If you have this matrix, I'm explaining it 2 by 2, but same thing can be extended for anything. So you'll see one thing here. If this is 1 2 3 minus 1, then ultimately, you know, lambda or a characteristic equation is something like characteristic equation is so it's a 2 by 2 ultimately, so lambda square minus lambda square minus trace of this matrix. Okay, so what is the trace? 1 minus 1, so 0. 0 is the trace. Clear? So if this is trace, then we don't have 0 element. 0 into lambda plus determinant. What is determinant? Minus 1 minus 6, so this is minus 7 times is equal to 0, of course. Okay, you know basically how to form these coefficients. I have told you even for 3 by 3 case. So if it's a 3 by 3, you would have written lambda cube minus trace plus sum of the principal minus into lambda plus this determinant is equal to minus of determinant is equal to 0, because you'll keep changing this plus minus signs alternatively. Okay, so anyway, now we can see we got lambda square minus 7 is equal to 0. This is the characteristic equation in this case. Okay, if this is the characteristic equation, now what Cayley-Hamilton theorem tells you is, okay, so this Cayley-Hamilton theorem gives, so if you replace lambda with a square, so since this is a matrix, minus 7 should be replaced with 7i, that's it, is equal to 0. So ultimately, you know, a square is equal to 7 times of i. That's how. Okay, so you can, without actually calculating the actual a square, you can tell is a square value. Okay, similarly you can tell about higher powers of a in general if you know this Cayley-Hamilton theorem, and many times in matrices with large sizes you can calculate the inverse very easily without you know, doing a lot of stuff actually. Okay, see how you can do that. I'll just give you a hint. Obviously, if you, let's check whether this a square will give us 7 times identity or not. Okay, so a square is going to be 1 2 3 minus 1, then 1 2 3 minus 1. So if you simplify this, let's say 1 plus 2 3s are 6, so total 7. Then 2 minus 2 0, 3 minus 3 0, 6 minus of minus 1 into minus 1, so sorry, 3 into 2 6 plus minus 1 into minus 1 is 1 again, which is 7. So you can see this is 7 times I, but you decided that this value is going to be 7 times I without actually calculating a square, just by using this Cayley-Hamilton theorem. Okay, so that's how the when Cayley-Hamilton theorem satisfies things. This 0 is of course the trace of the matrix, and obviously as you keep marching forward you will have some trace, then after sum of principal minus, then after determinant with plus minus alterations. Okay, I have told you how to generate a characteristic equation. Okay, now let's say we'll take one more matrix and we'll inspect. Like I'll show you the advantage of calculating inverse. Example, a is equal to, say for example 1 2 3 7 3 minus 4, maybe some numbers whatever you like, 2 minus 1 2. Okay, so let's say this is your matrix. Then if I ask you what is the way to calculate it, A inverse. Okay, so how to calculate this A inverse? Then you know the classical procedure, you should calculate 9 minus total. Okay, then after calculating this 9 minus, then you have to find cofactors, then calculate it, transpose it, you'll get adjoint. Okay, then divide it with determinant of A. You have to do all these things of course. Okay, but let's see without doing all these things how you can calculate A inverse. First of all, if you write the characteristic equation, I've told you just by looking at the matrix how to write the characteristic equation for 3 by 3. Characteristic equation is, so it's 3 by 3 ultimately, so lambda cube minus, because it's plus, so next will be minus trace. So what is trace? 1 plus 3 4, 4 plus 2 6, so 6 lambda square. Then here it is minus, so next it's going to be plus, sum of principal minus. So first let us calculate the minor of this element. Okay, so if you delete this row and this column and row, so 6 minus 4, so 6 minus 4 is 2. Then after minor of this element, 2 minus 6 minus 4 plus the last element 3 minus 14 minus 11 times lambda. Then you have used plus, then again minus. Now determinant value is equal to 0. So what is the determinant? Let's check. So determinant is 1 into 6 minus 4, so 2 minus 2 into 14 plus 8 22 plus 3 into minus 7 plus 6 minus 1. Okay, so ultimately this is 2, this is 44 of course, 44 and 3, 44 and 3 is 47, 47 plus 2, so minus 45. So determinant is minus 45, you know, at A is equal to minus 45. This is what you have. So minus 45 is equal to 0. So which means, you know, lambda cube minus 6 lambda square, then this is minus 15 plus 2 minus 13 lambda plus 45 is equal to 0 of course. Okay, so this is the characteristic equation. I have told you just by looking at the matrix and doing few calculations how to write this. Normally you need not expand the total 3 by the determinant and then multiplying the terms, factorizing. You need not do all these things of course to calculate this equation. Now as per Cayley-Hamilton theorem, it tells you something like Cayley-Hamilton theorem. This tells you ultimately a cube minus 6a square minus 13 times a plus 45 times identity matrix is equal to 0. Okay, so this is plus 45 into I is equal to 0. Okay, now if you multiply it with a inverse, multiplying with a inverse on both sides, of course, you will see you can decide whether it can multiply whether a inverse exists or not. If a inverse exists, then ultimately you'll have this constant term. Okay, this 45. If a inverse do not exist, then ultimately this determinant is 0. You won't have the constant term. Then Cayley-Hamilton doesn't work, of course. Okay, so if you multiply with a inverse, a square minus 6a minus 13 times a into a inverse is identity matrix plus 45 times a inverse is equal to 0. So what is a inverse from this equation? 1 by 45 times of 6a plus 13 times I minus a square is what you're gonna get. Okay, and you have generated an expression for a square. You can see, you feel that this calculation is a bit lengthy, but actually whenever you go for matrices beyond 5 by 5 and 6 by 6, this equation is actually very helpful. Okay, means this Cayley-Hamilton theorem is actually very helpful, because at such matrices, rather than calculating minus of, let's say for example, if you have 5 by 5 matrix, you have to calculate 25 minus, okay, to calculate the inverse. Okay, but if you know this technique, then ultimately calculating a square is much simple as compared to calculating minus of 25 elements. Okay, so that's why this Cayley-Hamilton theorem is very useful in general. Clear to all of you? Yes or no? Please type in the chat box. Did you understand how basically what Cayley-Hamilton theorem can actually help you? I'm afraid of calculus. I failed it several times. It gives me a panic attack. Oh my god. So I need to avoid this. Do you have any solution for this problem? Just attend the lectures, okay? And whenever we are starting from the base, please do follow. That's all. Okay. See, yes, anything can bring discomfort in your life only once or maximum twice. That's it. Okay. That's all. Once you face the problem, next time when it comes, you are not afraid. Okay. Let's say for example, if qualifying gate is one of your issues. Okay. Then you have qualified. If you it seems impossible only it's done for the first time. Okay, then after it's like a very common thing. Clear? It becomes a very common thing. Like first time when I have written gate examination back 8 years down the line, that's the first time I was in BTech final year then. So I felt like very a bit of I don't have anxiety, but a bit of less confident. Okay, feeling less confident is what I have. Then but once I have cleared it, then after every year I'm writing, every year I'm qualifying, and I've been doing well in gate examination. So it's like a matter of first time. That's it. Okay, clear? So anyway, this Cayley-Hamilton theorem actually helps you up. Now coming to one thing, actually the partition matrices, which people have asked. So partition matrices or partition matrix, or sometimes it's also called as block matrix. So let's see what's a partition matrix, or basically what does a block matrix can actually help you. Okay, now if you have a system, okay, you'll have a lot of systems which keep developing. Now if you have this system, okay, then if you take any matrix, for example, say matrix M is what you have, for example. So there is a matrix M and there is a system such that M X is equal to, or maybe I'll take some other variable, M alpha is equal to beta. Let's say this is what you have, and you have to solve for alpha, for example. Okay, then when you have to solve for this alpha, few times what happens here is this matrix M will not be full occupied. Okay, many of the elements of M would be zeros, or some part of M could be identity matrix. And then, like for example, I'll show you, if you maybe I'll show you one equation. So third diagonal in fluid mechanics in CFD is what one matrix I'll see. So third diagonal matrices in CFD will experience a lot of times. Okay, so third diagonal system for elliptic equations, what we can see. Anyway, we'll right now don't worry about what is an elliptic equation, what is a partial differential equation and all, but my main intention is to tell you, if you check sometimes, you can see this matrix. Okay, so there's something called Thomas algorithm, which will maybe we'll see in numerical methods, but right now don't worry about all these things. Right now just look at this story as this is a matrix and this is a vector and this is also one more vector. Okay, now if you for example identify this matrix, one thing that you can figure out is only these three diagonals, okay, so the principal diagonal, then the below diagonal, and the diagonal which is above. So only these three diagonals contains elements, and the rest of all elements are zeros, okay. So whenever you try to calculate this values of x1, x2 and so on till xn, few times what happens, the computer has to unnecessarily perform a lot of operations, okay. So to eliminate this, we will actually split this matrix into blocks, okay. So let's say, for example, I have taken a square matrix here, then maybe some part is here, there is one part here, and last part is here, okay. So this is what will actually divide. So whenever you have this matrix A can be partitioned like this, okay. So whenever you have this matrix, you can partition this matrix. So this is A, maybe B, C, and D, of course, okay. So these are called parts, of course, okay. So whenever you have a very big matrix, you can actually split it up into some blocks, okay. Maybe they can be square matrices or rectangular matrices, anything. Like let's say if this is of size m by m, for example, because I'm using m, then let's say A is of size n by n, okay. Then B is of size m minus n cross m minus n, of course, okay. So m minus n is what you have, right? So this is of size n by n, so this is of size n by m minus n. And what about C? C will be of size, so since you have covered m rows, so m minus n cross, you already have filled this n columns here, so C will also have n columns, of course, and D would have same thing like m minus n cross m minus n. So these are basically the matrices, okay. So you can split up this big matrix of size m by m into 4, maybe you can split into any number depending on your comfort. So you have this ABCD, that's what we call partitioning. Now the advantage of this partitioning is, few times, especially when you're dealing with tridiagonal systems or systems where we have majority of the elements as zeros, let's say for example when you're doing this performance, this A is identity matrix, for example, okay, or let's say the partition is such that these two are equal, so that this partition is symmetric, okay. So you have very special cases where the solution, the value of this alpha can be calculated with very easy calculations actually, okay. So anyway, let's see what we can do is, this alpha can also be written as some vector x bar and some vector y bar, where this, let's say for example, alpha is something like alpha 1, alpha 2, and so on, alpha n. Then ultimately this x is of size, it has some elements here. This can be written as x1, x2, and so on. You have how many elements you have here? So A is multiplied to this x, for example, okay. So you have m by n elements, so it should have n by 1. So n by 1, this is xn, and similarly you have maybe y1, y2, and so on, y m minus n. This is what you can have, of course, okay. So that you have total m elements here. So total you'll have n number of this is m, alpha m, because we have taken this as n m by m matrix. M is of size m by m. So this total consists of m elements. That m elements we are splitting it into two vectors, okay. So this is the first vector and this is the second vector, of course, okay. And we will actually calculate the things. Similarly, this beta can be split into maybe C1 and D1. Similarly, this beta can be split into two vectors. Maybe first vector is C1, let's say it has some columns, some rows, which is of size, it's a column matrix, of course, it has some rows, and a vector D1, of course, okay. So this is what we can do. The advantage of doing this kind of splitting is, you need not perform individual calculations for individual elements. In fact, using matrix operations, you can solve the system at a single go. I'll show you how we can do this. Let's say m alpha is equal to b, for example, and this m can be treated as A, B, C, D. It's a partition matrix, of course, okay. So it's a partition matrix, and this multiplied with x and y, okay. So these are the vectors which we have done. So this alpha is split into two parts, and ultimately C1 and what we have taken, C1 and D1, okay, fine. So let's say this is D1, clear. So this is C D1. Now exactly we have split this according to the sizes, okay. So we have split this x bar, y bar, C1, D1 depending on the size of this n by n. If this is of size n by n, then ultimately this x1 has got n elements, so that this matrix multiplication A with x is possible, okay. Similarly, this B is of size n by m minus n, so ultimately this has m minus n columns and this has m minus n rows, then ultimately this B can be multiplied to this vector y. Okay, so correspondingly we will generate c1 and d1, where c1 is of size n by 1 and this is m minus n by 1, of course. Okay, so these are the two vectors which when you add the combination you will again get the beta. Clear? First of all, the splitting up, is it clear? Then we'll see how to solve the systems. Okay, but first of all, please tell me, is the splitting up clear to all of you? How we can actually divide, or basically we can partition a big matrix. Is this clear to all of you? We'll see how to solve, but first of all, the partition is understandable or not? Every one of you, please type in the chat box. M minus n means number of total you have m rows and m columns in this matrix. It's of size m by m. So when you have partitioned it, we are taking n rows in the A and ultimately n rows and n columns in A. So ultimately B should have n minus n columns. Okay. See, whenever you write AB side by side, you will have total n columns. Okay. But A consisting n columns, it's of size n by n. So out of total m columns, if you have n columns in A, then ultimately number of columns here is m minus n. That's how. Okay. Did you understand? Okay. See, basically what I'm telling is, look, let's say I have a 4 by 4 matrix, for example. Okay, 1 2 3 4, 1 2 3 4, just some 3 by 4 matrix you take. Okay, if I take a 3 by 4 matrix, if I can partition this into this situation, then ultimately this is of size 2 by 3 and this total is of size 3 by 4. So total this matrix completely should have 4 columns. So if I take this part as one matrix A, which is of size 2 by 3, and if I call this as matrix B, then ultimately number of columns that I'm going to come here is 1, because this 3 plus 1 column will actually give me total 4 columns. That's why if this matrix consists of n columns, ultimately B should consist of m minus n columns. If you add these two, then ultimately total number of columns is m again. Okay. Similarly, if A consists of n rows, then B should also consist of n rows, because this is a horizontal line. So like you can see here it is 2 by 3, so here it's also 2 by 1. Okay, so this 2 is actually same in this case. That's how in general we are doing the partition. Okay, clear? Did you all get this? Yes or no? Please type in the chat box. Is this clear to each and every one of you or not now? Did you all understand how we have done the partition? Just a minute, I'll have water. Okay, Prabhat, everyone, is this clear how we are doing the partitioning? Okay, now yeah, now we'll see how this partitioning is effective for us. Okay, how it can help us in solving the system. Okay, so let's see how we can do this. So ultimately we got this system as A, B, C, D. We have partitioned this. Then this vector also we have partitioned into 2 vectors, and this also we have partitioned into D1, D1. But of course the partitioning is exactly in sync with this matrix M partitioning. Now let's see, if you simplify this, you have A into x bar plus B into y bar is equal to C1 bar, of course. Okay, and this C into x bar plus D into y bar is equal to D1 bar exactly. Okay, so this is D1 bar is what you can write. Okay, now let's see, if this is C x bar plus dy bar is equal to D1 bar, then from this equation, let's say if you want to calculate x, for example. Okay, how do we calculate? You can use elimination procedure, but it's not like you multiply C, B and C, D, then cancel and all. Okay, because whatever you do, this multiplication doesn't matter. So we'll go for elimination. Y is equal to, if you calculate y, how we will calculate y? This y is actually D1 minus C times x. This multiplied with D inverse. Okay, because these are matrices, you should not write 1 by D. These are matrices, everywhere we have matrix. So ultimately this is the expression for the y vector actually. Clear? So y can be calculated by using D inverse times D1 minus Cx, of course. Okay, now if you replace this in first equation, therefore Ax plus y. So what is y? D inverse d1 minus D inverse Cx is equal to C1, of course. Okay, so this is C1. Now if you take the coefficients which have a inside, so this gives up something like a minus D inverse, a minus b D inverse C, this complete thing multiplied with x operated on x, plus b D inverse D1 is equal to constant 1. You know this. Okay, so this is constant 1. So you can ultimately write this x is equal to a minus b D inverse C whole inverse, this total inverse multiplied with C1 minus b D inverse D1. This is what you'll get, correct? So this is how you can calculate what is x completely here. Okay, but the main interesting thing in this whole story is, of course, see, this is what you got expression, and here you have to calculate this D inverse. Only one inverse is what you have to calculate. See, in actual case, if you want to solve this system, okay, if you want to solve m alpha equal to b inverse, m alpha is equal to b inverse, you have to calculate inverse of this matrix M. Okay, and let's say if this is of size m by m, total there will be m square elements in this, and to calculate the inverse of this, you will definitely always calculate this total m square. Yes or no? You have to calculate minus of all those m square elements, right? Correct? Will you agree? If I want to calculate that inverse inverse, ultimately I'll have to calculate m. Basically I'll have to calculate all m by m minus. Okay, means total m square minus is what I have to calculate, which is very big operation. But in this case, if you want to calculate this x inverse, you have to calculate this D inverse. Okay, so only D inverse, and of course the inverse of this matrix as well. But you can observe one thing: the size of any of these matrices would be definitely less than the size of m by m. Okay, and also this partitioning will actually make one thing very simple. Let's say this complete matrix M, you have some m square elements. Let's say the total matrix M is singular, for example. Okay, then ultimately you cannot solve alpha is equal to m inverse b, because m inverse does not exist. But when this complete matrix is singular, there can be a chances where this part, if you take this small part may not be singular. Yes or no? Correct? And for calculation of x and y, you need only this D inverse. So definitely if this is non-singular, then still you can solve this system. Correct? Did you understand the advantage of partitioning the things? Yes? So please type in the chat box. Is this clear to all of you? Did you understand why we are interested in the partitioning business? Especially when the matrices consist of lot of things. Okay? Fine? Okay, now let's see. So this is how you'll actually calculate x, and here you'll observe one thing. This matrix, because A minus B D inverse C is what you have, this A minus B D inverse C, this matrix is called Schur's complement of D, of course. Okay, so this is called Schur's complement of D, of course. Okay, so can we solve 4 by 5 matrix from this? Yeah, you can solve even 1000 by 1000 also. Okay, just pick 999 by 991 as 1 and 1 by 1 as last, or maybe 2 by 2 as the last small part. So just calculate the inverse of the 2 by 2. That's very simple, and you can use this technique. Okay, now if you replace this in that, we'll get the value of y also. Okay, so this is called the Schur's complement, or Schur's complement basically of this D inverse of D, of course. Okay, so Schur's complement of D. So just by calculating this D inverse and putting it here, you can calculate this x, because everything is rest all is matrix multiplication. That's it. Okay, so multiplications are very simple to calculate the solution. You can calculate of any size. Okay, and in fact you can use this technique for non-square matrices also. Okay, let's say for example I have a matrix of size 4 by 5. Okay, whenever I have a matrix of size 4 by 5, see, for example, if I have one more column and one more row, for example, so 1 1 1 1 1 1 1 1. Okay, so clearly it's of size 4 by 5. Now in this case this is of size 4 by 5 of course. Okay, so let's say maybe for the comfort I am telling this, this is 2 different elements we are having. Now if this is 4 by 5, then you can, it's a non-linear system of, I'm sorry, it's a linear system, but it's of non-square matrix. Then when it is non-square matrix, by framing a 2 by 2 here, you can calculate what is D inverse and you can keep performing this operation. Okay, so that's how this vector can be completely calculated using some matrix multiplications and calculating inverse of D. And once you get this, you can also calculate this very easily. Okay, it is almost like substitution. Okay, so this calculating X inverse is the main stuff. Once you get this X inverse, just replacing this X inverse here will give you this complete Y. Okay, which means these two are connected of course, and identifying one will just give the other in very few steps. Okay, that's how this complete block of elements with the help of matrices, this complete block is calculated in a single go, and once this is known, this can also be calculated in very few operations. Okay, that's why we have the advantage of dealing with partitioning matrix. Now one important stuff that comes here is, few times what happens, this B comes out to be a symmetric matrix. Okay, B comes out to be a symmetric matrix, which means B can be written as B transpose. Now when you're using some properties of inverse and all, things get simpled easily. And few times this B can also be an D. Okay, the last matrix D can also be an orthogonal matrix. Okay, so whenever it's an orthogonal matrix, this D inverse is just D transpose and things would be very simple. Okay, you need not even calculate the inverse then in that case of D, you just transpose it. So if D is orthogonal matrix, D is same as D transpose, and if you just put D transpose and simplify, you can solve. Okay, fine. So is this clear to each and every one of you why we are dealing all this partition matrices or other things basically? Okay, yeah, correct or wrong? Please type in the chat box. Is this true? Is this clear to all of you? Okay, right, please type in the chat box here. You're understanding the things or not? Yeah, examples this. Okay, this is what I have told you just now. Okay, so let's say you have a matrix like this, then you can take out some part out of that. Okay, and calculate the inverse and then apply these rules, which can give you, let me write for Y also, and Y bar is equal to D inverse times, okay, D inverse times D1 minus C times. Okay, so I think this I have written C and this is C1 and D1. Okay, fine, you can recognize. So D1 into C into X. So what is X? A minus B D inverse C whole inverse multiplied with C1 minus B D inverse D1. This is how you have the elements of the. Okay, and of course normally when the matrix size goes beyond a very large value, we'll just use programming using this simple identification of partitioning. How do we calculate the determinants of the partition matrix? See, basically you can calculate this whole determinant is what you have. Okay, so A, see, for example, if this is a non-square matrix, first of all, for calculating the determinants, we'll check the determinants matrix, and once you have the determinant matrix, you can apply any equivalent form or anything to make the to calculate the det very easily. Okay, so let's go to the applications. Okay, we have few more things to deal. Okay, so this is basically about the partition matrix, and of course last year is the first time when they have introduced data science paper, and last year there is no question on partition matrix of course, so we'll see what happens this. Okay, hello, let's before we go for mean value theorems, I would like to give few points actually. Okay, some standard limits is what you can do. Some standard limits which would help you. Okay, so let's see some standard limits. So first let us see limit x tends to a, x power n minus a power n divided by x minus a. This would be n into a power n minus 1. So similarly, limit x tends to a, x power m minus a power m divided by x power n minus a power n. This gives you m by n times a to the power m minus n of course. Okay, so m by n into a to the power m minus n. Then let's see limit x tends to 0, sin ax by x is equal to limit x tends to 0, tan ax by x. This is also equal to a, of course. Okay, so this is a. Then 4, limit x tends to 0, 1 minus cos x by x square is equal to a square by 2. Guys, please remember, many times in GATE to confuse you, they'll don't give x square here, they'll just give you only 1x. If they give you only 1x, the answer is 0. Okay, because ultimately, you know, if you have limit x tends to 0, 1 minus cos x by x, okay, then you can do this as a multiplication with x and write it x square. So this can be written as limit x tends to 0, 1 minus cos x by x square, this guy, into limit x tends to 0, x is what you have. Okay, so ultimately, you know, this gives you a square by 2, but this gives you 0, so this is 0. So please make sure whether you have x or x square here when you are calculating this limits. Okay, because many times people have habituated to write these shortcuts and they don't actually remember the question. Okay, so please keep this in mind. Then we have few more things which we can write. 5, limit x tends to 0, e power ax minus 1 divided by x. Okay, so if you try to simplify this, then we have e power ax minus 1 divided by x is log a to the base e, correct? So this is log a. Just a minute, we'll calculate this. Okay, so log a power x minus 1, let's take here a power x minus 1 is equal to log a to the base e, of course. Okay, so log a to the base e, because if you apply L'Hospital, a power x into log a to the base e, so we have to do correct. Okay, so this is log a to the base e. Then you can write few more limits. See, all this can be calculated using L'Hospital. Okay, till here it can be calculated using L'Hospital's rule, of course. Then 6, limit x tends to 0, a power x plus b power x minus 1 by 2 whole power 1 by x is equal to, so let's say you have this limit, for example. Okay, so such that it gives you the form 1 to the power infinity, because when you put x equal to 0, a power 0 is 1, b power 0 is 1, and minus 1, so this total becomes 1 by 2 power, you know, basically we have a power x plus, okay, just a minute, I think I have made some small mistake when writing this, a power x plus b power x by 2 minus 1. Okay, so a power x plus b power x by 2 minus 1 whole power 1 by x. Okay, so you can see when you put x equal to 0, this is 1, so 1 by 2, sorry, 2 by 2 is 1, 1 minus 1, 0, no, just a minute, then this minus 1 is not there, maybe. Okay, yeah, whole power 1 by x, correct. So this gives you correct 1 power infinity, so this is square root of ab. Okay, so this is square root of ab. You can actually do that. The reason for that is, why you can do this is, I'll just show you how to get this result. Limit x tends to 0, a power x plus b power x by 2 whole to the power 1 by x. This gives you something like 1 to the power infinity, correct? Because if you put x equal to 0, then ultimately that gives you 1 to the power infinity. Then you can see in last class I have given one expression which could help you. If limit x tends to infinity, f of x power g of x is 1 power infinity, then okay, so then limit x tends to infinity, f of x power g of x is equal to e to the power limit x tends to infinity. In fact, x tends to any limit a, you know, you can keep a to generalize the things. X tends to a is 1 power infinity, then x tends to a is equal to e power limit x tends to a g of x into f of x minus 1. This is what we have seen. Okay, so this is the expression that I have given you in the last lecture. So since if you put x equal to 0, this gives you the form 1 power infinity. So what you can do is you can apply this, and let's try to get this down. Therefore, limit x tends to infinity, a power x plus b power x by 2 whole power 1 by x is equal to e to the power limit x tends to infinity, g of x. So what is g of x? Of course 1 by x into f of x minus 1, a power x plus b power x by 2 minus 1. This is what you have. Okay, So if you simplify this, let's see what we'll get. This is equal to e power limit x tends to infinity. You can write this as, if you take LCM, you have a power x plus b power x minus 2 divided by 2. We can write that as a power x minus 1 plus b power x minus 1 divided by x, and this 1 by 2, which is a constant, you can bring it outside the limit. Okay, so 1 by 2 is constant, you can bring it outside the limit. Then ultimately, since limit can be split up at plus sign, so in fact at any sign, of course, so limit x tends to infinity, this a power x minus 1 by x, this term will actually give you log a to the base e. Okay, this is the limit what I've given you. If you apply L'Hospital, you will get the answer, because if you put x equal to 0, this gives you 0 by 0 form. So upon applying L'Hospital, it gives you log a to the base e. And here, if you pull out this 1 by 2, then e power limit x tends to infinity, you have sum of two limits. So as per this logic, you will have e power half times ln a plus ln b, log b to the base e, of course. Okay, so this is what you have. Now when you have sum of two logs, you have log a plus log b, then ultimately log ab is what you have. So e to the power half ln ab. So this half, which is in the multiplication of log, can be thrown into the power. So e power ln square root of ab, which is root ab, because log, basically a power log a, log something to the base a is that something. So therefore this value is root ab. Okay, yeah, this is correct. Fine. Anyway, so you can check this is the things. The properties that we have used here is this half, when it goes to this power, basically the two logarithm properties which you can use is n times ln x to the base a can be written as ln x power n to the base a. This is one thing. And one more thing is a power log x to the base a is equal to x. That's it. Okay, so these two properties is what I have used in simplifying this things, of course. Okay, is this clear to all of you? Yes or no? Do you know these two properties? Do you know these two properties? Do anyone of you know? If some of you don't know, I'll explain you. This logs, of course, it's like some 9th class or 10th class stuff, but still I'll explain you. If some of you don't know, please say no, then I'll explain how these things are coming. Only one of them you know. Okay, which one? The first one or the second one? Top or the bottom? No idea. If some of you don't know, please ask me. I'll definitely clarify. Okay, or if you know, then it's fine. Okay, everybody knows, I guess. None of you is typing. Okay, good. Okay, so doesn't know the second. Okay, second one you don't know. Fine. Maybe if you have studied this, aptitude, basic school math, you can understand. The definition of logarithm is if a power x is equal to n, this implies log n to the base a is equal to x. This is how the log is defined. Correct? Yeah. Will you agree? This is how the log is defined. Now you can consider one thing. This implies a power log n to the base a is equal to a power x, because these two are equal. So this will be equal to this. But what is a power x? N. So this implies a log n to the base a on the power is equal to n. Okay. Clear? Okay. We are keeping the base same. Okay, so ultimately this a power x turns out to be n, and this complete expression gives you n. Fine. Hello. Let's okay, I hope this is clear. So in general, if you have a limit like this, similarly, one general limit which I would like to give is 6 or 7. Limit x tends to 0, 1 power x plus 2 power x and so on plus n to the power x divided by n whole power 1 by x, which is of the form 1 power infinity. This is of the form nth root of n factorial is what we have. Okay, so this is nth root of n factorial. Clear? So like for example, you see whenever you have only two numbers, 2 root of product of these two, which is square root of ab. So let's see, this is one again important thing which you have, of course. So yeah, tan we have taught, and this kind of things we have taught. Then 8, in last class I have told you, if limit x tends to a, f of x is equal to 0, then limit x tends to a, f of x power f of x, this is always equal to 1. Okay, in bracket please write, this is 0 power 0 in general is not equal to 1. Okay, so this 0 power 0 is not equal to 1, but this one comes up because of some logic what I told you. So based on this, there are a lot of gate questions which came. Now I would like to ask you one limit. I hope you all will answer me. Limit x tends to 0 or infinity, let's say infinity, sin x by x. What is this value? Can anyone tell me? Limit x tends to infinity, 1 plus x, limit x tends to infinity, sin x by x. What is the value of this? What is the value of this limit x tends to infinity, sin x by x? Zero? Why it should be 0? It could be something else, right? Limit x tends to infinity, sin x by 0, sin x by x. 0, 2. Yeah, of course it is 0. Okay, because in the graph yesterday I have given you the as x increases, the sin x by x value keeps dying down and it goes to 0. And here you can see the reason for this is, whatever you keep in place of x, you will always have a finite value in -1 to 1, of course. So this divided by a very large number. Okay, so this tends to 0. Of course, a finite value in -1 to 1 divided by a very large number gives you a very number which is very close to 0, of course. Okay, so this is one thing. Then you can see 10th question. 10th, limit x tends to 0, 1 plus ax whole power b by x is same as limit x tends to infinity, 1 plus a by x whole power x. Okay, so whole power bx, let's say bx. In both these cases the value is e power ab. Okay, you can see they give you the form 1 power infinity. So if you do the classical procedure, you will, and see basically this gives you 1 power infinity form, and if you apply this result, then ultimately this gives you e power ab, of course. Okay, these are also very important things which save you some time. Okay, so these are some standard limits which could keep rolling out again and again in gate examination. Okay, so this, it could, you know, it could slightly save time, but of course these are something which you need to mandatorily know. Even if you don't know, if you know the techniques, you can derive at any point. Okay, so let's solve one question, actually this question. Okay, so let's solve. The following inequality is true for all x close to 0. What is the value of limit x tends to infinity, x into sin x by 1 minus cos x? I'll give you some time. Okay, so maybe some 60 seconds is what I'll give you. Come on, solve this question. It's a nice question actually. Okay, there is something called sandwich theorem in maths which you can see now, of course, but if some of you have any idea, you can try this question. Come on, do it. Ragnika 1 maybe. Okay, time got finished, but anyway, let's check. Okay, so let's check it up. What is the answer? The first thing which I would like to tell you is, first of all, what is the sandwich theorem is what you have to know. Let's say if you have 2 less than x less than 2, for example. Okay, so let's say you have a number like this. the value of x is trapped between 2. Okay, means this is 2 and this is also 2. That means x should stay at 2. It cannot move anywhere. Correct? Yes or no? If you see on an aerial line, if you have a aerial line, of course, you have aerial line, and let's say this is the value x is equal to 2, and let's say the upper limit and lower limit of this x is only 2. Okay, so that means this value of x has to be at 2. Doesn't matter. It cannot move anywhere. Okay, so therefore in such cases x is equal to 2. That's what you call sandwich theorem. Means whenever it's fixed by, it's locked by 2 limits here, but if both the limits are same, then ultimately the value of this function is the value of the limit itself. Okay, so let's see what we can calculate. Of course, if this is true for all x close to 0, limit x tends to 0, 2 minus x square by 3 less than limit x tends to 0, x sin x by 1 minus cos x less than limit x tends to 0, 2. This is what we have. Okay, so if you simplify this, this implies if you put x equal to 0, this limit gives you 2 less than limit x tends to 0, x sin x by 1 minus cos x less than limit x tends to 0, 2 is 2 again. Okay, because you don't have x to substitute 0. So that means this limit will lie between 2 as lower and 2 as upper limit. Therefore this implies limit x tends to 0, x times sin x by 1 minus cos x. This value is definitely 2 in this case. Okay, so this is of course 2. Clear? That's how. Even without knowing this knowledge, if you try to calculate this limit, still you will get 2. Okay, which I can show you easily. I think when many of you might have forgotten one thing. Many of you might have forgotten one thing, so that's why you are entering 1. But let's see, if you want to basically solve this, limit x tends to 0, x sin x by 1 minus cos x. Okay, so let's say you have this. You can write this as limit x tends to 0, x sin x by 1 minus cos x. You divide with x square on both numerator and denominator. So if you denote, ultimately this limit if you split, okay, so this is of the form limit x tends to 0, sin x by x divided by limit x tends to 0, 1 minus cos x divided by x square. Okay, so ultimately this value is 1, this value is 1 by 2, so the total answer is 2. That's it. Okay, so even if you don't know this logic, still by just calculating this, you can say the answer is 2, or you can apply L'Hospital or whatever. You have a lot of things to do. So whatever you do, you can clearly figure out this value is 2, of course. Okay, but to make you eliminate this process, they have already given you this inequality. So they want to tell you that as x tends to 0, ultimately this function, okay, this function will lie at 2 because the lower and upper bounds are 2. So ultimately this function has to be 2. So if you know this logic, you need not do this calculation. Clear? Okay, Prabhat, Sagnika, Ashwini, Alex, Ajay, Gautami, every one of you. Yeah, so please type in the chat box. Is this clear to all of you? Yes or no? Type a bit fast, quick. Did you all understand why it's 2? Because since you guys have given 1, so I know there's some bit drawback. So that's all. Now I just want to solve few questions before we okay, solve this question once again. So with a 1 unit change in b, so if you are changing b by 1 unit, what is the change in x in the solution of the system equations? Okay, so which means y is fixed. So if b is changed by some amount, what is the change in x? That's what. Okay, so what is the change in x that could give a change of 2 units, a change of 1 unit in b? Come on, think. Anyway, for this question the answer is 2. I think none of you have answered. Fine. So for this question, single choice, I'm giving you 120 seconds, or maybe 150 seconds you take. It's okay. Solve the issue. So there are 2 equations which are connected, linear equations, and if your b has to change by 1 unit, what should be the change in x? That's the question. Okay, solve. It's again a previous year question, solved many times, of course. Come on, solve this quickly. B is coming 2 units maybe. Okay, let's see. Everyone should try. It could be B, maybe it's possible because B is in one of the option. Fast, come on, quick. Come on guys, quick. See what some of you are feeling. See, I gave you time for thinking. Okay, actually if you know the concept to solve this you need only 30 seconds. Okay, but you who want to think, they have to think. Okay, so that's why I have given some time. Okay, yeah, C is what Ashwini is feeling. Okay, so let's see if you solve this question. So first of all, they are asking you, with a 1 unit change in B, what is the change in X? This is what you want, correct? So which means you see here, they want you to calculate dx by dv, correct? This is what, for a 1 unit change in B means if db equal to 1, what is dx? That's what, which means you have to calculate what is dx by dv. That's what they're asking, correct? From the definition of differentiation, when B changes by 1 unit, what is the corresponding change in X? That's what they're asking. So first of all, what is the connectivity between X and B? Let us figure out. Okay, what is the connectivity? So let's see, let's eliminate y from these two equations so that you can have connection between X and B directly. Okay, so let's see, if you maybe if you multiply 0.99, okay, so this implies 0.99x plus 0.99y is equal to 0.99 into 2, 1.98, of course. Okay, so 1.98 is what you have, and this equation gives you 1.01x plus 0.99y, because I have intentionally multiplied 0.99 because I want to eliminate y. So this is B, of course. Now this is equation 1 maybe, and this guy is equation 2. Now 2 minus 1 gives you something like 1.01 minus 0.09 gives you 0.02. X is equal to, this gets cancelled, of course, B minus 1.98. So this is the connectivity between X and B directly. Now what they're asking you, when B changes by 1 unit, what is the change in X? Which means you have to figure out what is the value of dx by dv. Okay, so let's see, if you differentiate this equation, we get 0.02 dx by db is equal to 1. And what is dx by db? Because if you're differentiating with respect to B, then this x becomes derivative of x becomes dx by dv, derivative of b becomes 1, and derivative of constant is 0. So 1 by 0.02. So this is 50, of course, correct? Now 51 50 units what we have. Okay, so therefore change in X is equal to 50 times change in B. This is what you can clearly understand. So for a unit change in B, ultimately change in X is 50 units. Simple definition of differentiation. It's even a previous year gate question. Okay, so 50 units is the correct answer. Clear? Did you all understand why it's C? So let's check it up in the poll. So C, so 50% of Alex has answered it correct in 1 seconds maybe, but I think few more C's. Okay, but I think they are after the time. Okay, Ashwini, I think because of typing capital C your answer was not taken, I think. Okay, so anyway, let's see, this is one thing again. Then let's talk about few nice points here. So ultimately first, limit x tends to a, f of x plus or minus maybe g of x. If you have something like this, this can be written into two separate limits. limit x tends to a, f of x plus or minus limit x tends to a, g of x is what we have. Okay, so that's something. Then second, limit x tends to a, f of x into g of x. If you have the product of f of x and g of x, then ultimately you can write this limit x tends to a, f of x is what we have multiplied with limit x tends to a, g of x. Okay, so that's what we have. Then the third thing is, I just want to give you, and of course if you have a division here, same thing holds, of course. Limit x tends to a, f of x by g of x, if you have, for example, then this can be written as two separate limits x tends to a, because ultimately it's the ratio of the functions at that value of x. So g of x, this is what. These 3 points are very much common, known to you, of course, there is nothing big deal. But the fourth point is really a bit nice point. If limit x tends to a, f of x does not exist, and limit x tends to a, g of x does not exist. Okay, maybe or you can say and or anything, and or this does not exist, then first point, limit x tends to a, f of x into g of x may exist. This product may exist. Okay, means if individually one of the limits is not existing, but if you take the product of the two functions, then that product will may have some value actually. Okay, I'll show you quickly. Example, you all know limit x tends to 0 sin x, which is a very quite common example. You know this is 0, it exists. Okay, the answer is 0. Then second, you know limit x tends to 0 1 by x. I have shown you clearly this does not exist. Okay, so x tends to 0 1 by x does not exist, because I've shown you using the graph of y equal to 1 by x. In the right neighborhood the value is plus infinity, and in the left neighborhood the value is minus infinity. The function is continuous at that point, and ultimately this limit does not exist. Okay, but if you check the product of these two functions, but limit x tends to 0 sin x into 1 by x. So if you take this, then this is nothing but limit x tends to 0 sin x by x, and of course this value is 1. Okay, so that exists. Okay, so that's why even individually some of the limits are creating problem or issue, but when you multiply them or when you divide them, then the problem gets resolved few times. Okay, so that's how this is a very important. Clear? And coming to the concepts of differentiability, I would like to just give one point which we have dealt in last class, of course. The points where mod f of x, well, some polynomial function f of x or some polynomial function, or you know basically some function f of x, you can say it can be polynomial, it can be trigonometric, anything. So the points where mod f of x is not differentiable is, or basically are not differentiable, are differentiable are the points where f of x is equal to 0, where f of x is equal to 0. The reason why at all these points where f of x equal to 0 the function is not differentiable is because at the points where f of x is equal to 0, at all these points they generate sharp edges. Okay, and at any sharp edge function is not differentiable, you know, because why at a sharp edge function is not differentiable? Let's see. If you have a function like this such that it's generating a sharp edge, okay, and after this it's changing, and here also there is some change, but exactly at this point it is generating a sharp edge. So when it's generating a sharp edge, the left neighborhood, if you take the tangent to this function, so the tangent appears something like this. Okay, so in the left neighborhood the tangent appears something like this. So if this is my x-axis, okay, so let's say this is my x-axis in general, then ultimately this tangent is making an angle more than 90, so slope is negative. And whenever you go for the right neighborhood, of course, so in the right neighborhood what happens is this value is actually making a positive slope. Clear? And ultimately these two slopes are not equal because one is negative and one is positive, and of course they are non-zero. So clearly this, at this sharp point in both the neighborhoods, slopes will be different, okay, because of the orientation of the tangents. So therefore at all these points, because at all points where f of x is equal to 0, the function produces sharp edges. Produces sharp edges, of course. Okay, so the function produces sharp edges. Clear? So this is a very important thing. Like you see mod x, for example, okay, you take this function mod x, then ultimately f of x is equal to x. Okay, so the point where f of x equal to 0 is nothing but x equal to 0. So at mod x, at x equal to 0, mod x is not differentiable. Clear? So example, I like to write few functions. Example, so mod x is not differentiable, is not differentiable, mod x is not differentiable at this function. So the function inside the modulus, if you call that f of x, so this is x is my f of x, so f of x equal to 0, that means x is equal to 0, and obviously we have proven this many times. So second, mod sin x, if you take for example, this is not differentiable, at the points where sin x is equal to 0. Okay, so sin x is equal to 0, that is at x is equal to 0 plus minus pi plus or minus 2 pi, okay, and so on. Of course at all these points the function is not differentiable. Okay, fine. Like you can see, like if you for example plot this sin mod x, I'll just show you. It's very easy, you can interpret. Okay, sin x always lies between -1 to 1, so mod sin x always lies between 0 to 1. Okay, so if this lies between 0 to 1, then ultimately the graph comes like a loop. That's it. Okay, such that this value is y equal to 1. This value is y is equal to 1, x, y, of course, and clearly you can see at all these points this is pi, this is 2 pi, okay, this is 0, then minus pi, minus 2 pi. At all these points it generates sharp edge, okay, which is similar to this. So if you just plot, and I can maybe show in Desmos because you have Desmos. So mod sin x, if you plot, you'll see, okay, so mod sin x is what I'm plotting, of course, basically. So you'll see this is the mod sin x function I have plotted, so you can check it comes up like a badge like this. Okay, and all these loops are bounded by this -1, and if you take any loop, for example, you see here it's a sharp edge. Okay, it's similar to the mod x the loop what you have. Okay, so in fact if you go to any sharp edge, you go to any 0, it again generates a sharp edge. So at all these sharp edges, ultimately this function doesn't become differentiable. Clear to all of you? Yeah, is it understandable to all of you or not? So please type in the chat box. Clear? This point is very important because many times few questions actually come up again. So what about mod tan x? Mod tan x is like, again, yeah, correct, at the points where at x is equal to 0 it generates sharp edge. Okay, so if you want to see, because in mod tan x what happens if you take the interval minus pi by 2 to pi by 2, from minus pi by 2 to 0 it is actually negative. Okay, so if it gets flipped, it's like symmetric about y-axis. Okay, so it becomes symmetric about y-axis because obviously tan minus x is minus tan x, so the graph becomes symmetric about y-axis. I'll show you maybe if you're interested, because anyhow we have plotter. So let's see. Okay, so you can see this is mod tan x, of course, and if you make a close view, so this is symmetric. Of course they go to infinity, but within the range, if you see at all points where the value of function is 0, then ultimately there's a sharp edge again. Okay, so you can zoom in much more to see the clear sharp edge. This part is almost like mod x. Okay, so that's what, keep zooming in the things, you'll keep understanding a lot of nice things actually. Clear? So we'll solve few questions again before we go to the mean value theorems or whatever. So let's see. Come on, solve this question. At x equal to 0, the function f of x is equal to mod sine 2 pi x by L, where x goes from minus infinity to infinity. L is some constant which is positive, is dash. Continuous, differentiable, not continuous, not differentiable. Come on, think. Single choice. Maybe some 90 seconds is what I'm giving. Faster. Do it a bit fast. Quick. Continuous and differentiable, not continuous and not differentiable. B, D, about A and C. Ready? Hello. Fine. I have ended up the poll. Now let's see. The correct answer is of course continuous but not differentiable. Continuous but not differentiable. Okay. So you can see simple, like you can. I think many of you might be calculating the continuity of this function and all. Whenever we have this mod functions are always continuous function. Okay. And the only place where it's not differentiable is basically the points where sine 2 pi x is equal to 0. So at x equal to 0, ultimately the function inside the modulus is 0. Okay, so that's why A is the correct answer. So at basically if you take this function f of x is equal to mod sine 2 pi x by L. If you take this function, this is continuous always, because why it's continuous is continuous. The reason why it's continuous is because whenever you take sine function is always continuous. Okay, the only thing it has is plus minus sign variations. Now when you put a modulus, it comes to be positive for all values of x. That's what, right? There is no variation in the, means there is no point where it breaks actually, but the function is smooth. But instead of having negative and positive alternatives, it has continuous positives, which I have just shown, okay, in Desmos. Now similarly, if you can see this, it is not differentiable at the points. It is not differentiable at the points. It is not differentiable at the points where sine 2 pi x by L is equal to 0. This implies 2 pi x by L should be equal to n pi, where of course n is equal to 0 plus or minus 1 plus or minus 2, whatever. You have a lot of integers. Then if you simplify this, then pi and pi gets cancelled. So x is equal to nl by 2. These are the points. If L is defined, then at all these points where n is equal to again 0 plus minus 1 plus minus 2, at all these points it is not differentiable. Okay, and at n equal to 0, ultimately x is also 0. So this is one point where this function is not differentiable clearly. Okay, so therefore at x equal to 0, this n at n equal to 0, there comes a point x equal to 0, and at that x equal to 0, this function is not differentiable. Clear? So option A is the correct answer. Got it? So yeah, D would be reasonably the correct answer. Let's see. 50% of you. Prabhat has answered it on time and correctly, I think. Yeah, Prabhat has typed D. Yeah, Ashwini, you have typed maybe after the time, so that's why you don't have. We'll solve one more question actually. So okay, I'll give you this question homework. So you figure out of these functions, which function is not continuous at x equal to 3. Okay, so this question I'm giving you homework. You please try it. Now we'll quickly move on to the mean value theorems. Okay, so let's go to mean value theorems. So the first mean value theorem which Means basically what does the mean value theorem tells you, of course. Okay, so if you look at a mean value theorem, it tells about the value of the function at some point. Okay, the name itself tells you mean value. The value of x, which is somewhere in between the limits, can be calculated, okay, using this mean value theorems. So let's see what is this mean value theorems, and physically I'll explain you where it is much useful. Of course, you have a lot of instances. First is Lagrange's mean value theorem. Lagrange's mean value theorem. Okay, so it is Lagrange's mean value theorem. So let's see, if you calculate, if you see what is Lagrange's mean value theorem, if f of x is continuous, if f of x is continuous in a comma b closed interval, and differentiable in open interval a comma b, then there exists at least one value of x such that, okay, so there exists at least one value of x such that x belongs to open interval a comma b, and f dash of c is equal to f of b minus f of a divided by b minus a, of course. Okay, so this is what you have. So f dash of c is given by this. So what is the physical meaning of this? Okay, so fine, you know the formula, good, you are happy, but what does this formula actually tells you? Okay, so that's what you have to understand. See, because frankly speaking, formula wise it's only up to this point, but if you know only this point, there are questions in GATE examination where you cannot answer. Okay, and even in many textbooks, unfortunately, you will find only this, but nothing else you will find. Okay, but let's understand what this actually tells you geometrically. If you take this if you take this curve, okay, so let's say you have this x-axis and you also have y-axis. Okay, I'm taking first quadrant so that general, so x and y, let's say. If you take this function, so let's say you have some function like this, a random function. Okay, so whenever you have this y equal to f of x, of course this is y is equal to f of x. Now let's take 2 points of x such that it overlaps this function. So let's say this is my x, for example. In fact, you can take somewhere anywhere in between, doesn't matter. I'm taking the ends so that I have some space to write the things. So let's say this is x is equal to a, and this is x is equal to b, of course. Okay, so this is x equal to b and this is x equal to a. Now if this is x is equal to a, then ultimately this point which is here will give us f of a, correct? To this value is f of a. Similarly, if this is b, then ultimately this value is f of b. Just a minute, maybe I'll. Okay, so let's check it. So we have, this is the function y equal to f of x, of course. So this is the function y is equal to f of x. Okay, so this limit here is f of b actually. Now if that is f of b and this function is y equal to f of x, this is x equal to a, f of a, x equal to b, f of b simultaneously, then if you call this as point a, for example, if you call this point a and if you call this point b general, then if I want to add the coordinates of this point a, ultimately the x coordinate of point a is small a and y coordinate is f of a, correct? Similarly, if I want to add the coordinates here, b comma f of b, will you all agree? Yes or no? Please type in the chat box. Will you all agree with this? If this point is capital A comma f of a, and that point is capital B, then the coordinates of that point B is small b comma f of small b, right? Because this is the function y equal to f of x. So yes or no? Please type in the chat box. Right? Now, if I connect these two with the help of a straight line, so let's say I'm connecting these two guys with the help of a straight line. Okay, so I've connected this as with this the help of a straight line actually. So can someone tell me, if I calculate slope of AB, what would be the value of slope of AB actually? What is the value of slope of AB? You know, AB is the line segment passing through the points A, which has this coordinates small a comma f of small a, and B has the coordinates small b comma f of small b. So if there's a line segment which is passing through A and B, then ultimately slope of this line AB is nothing but the right hand side of this equation, correct? Yes, because slope of AB is y2 minus y1 by x2 minus x1 is what you have, correct? So the slope of this line is nothing but the right hand side of this equation. So agreed, all of you? So please type in the chat box. Is this clear to all of you? Yes or no? Correct. Now let's see what is f dash of c. Of course, you know, I have given you one point. If you have any function f of x and if you calculate f dash of a, this f dash of a is nothing but slope of tangent to the function at the point x equal to a, correct? Okay, so let's see. If you calculate f dash of a, of course, then the slope of tangent to the curve, slope of tangent to the curve at x is equal to c is f dash of c, of course. Okay, so this is f dash of c, because ultimately if you take any point c, then ultimately the slope of the tangent to the function at that point c is nothing but f dash of c, of course. Okay, now if these two are equal, when slopes of two lines are equal, what does the, let's say for example this is the tangent and AB is the line segment, you know, if slope of AB and slope of tangent are equal, that means what is the relation between those two? What's the relation between those two? If slope of tangent and slope of the line segment are equal, that means what's the connection between those two? Connection between the line segment and the tangent? Connection between these two? Both lines are parallel. Yes, correct. Okay, they are parallel to each other, which means whenever you have a curve which is continuous and differentiable like this, at least at one point, at least at one point, you will have a point where the tangent will be parallel to the line. Maybe you can have two, you can have three, as many you can have, but at least there will be one point. Like for example, you see here at this point the tangent is parallel. Okay, this line AB and this tangent both are parallel, and this point is C, of course. Okay, so this point is of course C is what we have. Clear? So this is 2. Fine. Okay, so let's see, this point is x equal to a and this is x equal to b and this point is c. So that's what mean value theorem tells you. Whenever you have a continuous curve such that it's continuous and differentiable, whenever you have a curve it's continuous and differentiable between two limits, at least between those 2 points, at least there will be one point such that the slope of the tangent will be parallel to the line connecting both the points actually. And this you can actually use it many places. Like I'll give you one physical example. Okay, so let's say you have a road, for example. Okay, so you have a road. I'll just tell you one thing. Nowadays, you know, there are something called speed guns. Okay, you know, there's a speed gun, of course, which measures the speed of the vehicle, of course. So what technology that our government uses in general is they'll put one speed gun here and maybe speed guns here. They'll put individual speed guns, okay, and they'll check. Let's say this is the road and vehicle is moving, and let's say on this road the speed limit is 80 kilometers per hour. Okay, let's say this is 80 kilometers per hour. Then if 60 kilometers per hour is the speed limit, let's take the calculations easy. So 60 kilometers per hour is the speed limit. Then what they do, they'll keep a speed gun here and they'll observe whether any vehicle is coming with a speed more than 60. Okay, and citizens are good enough, they are clever enough. By the time they know there is a speed gun here, by the time they come here, they'll very slow their vehicle and they'll make sure the speed of the vehicle is below 60 so that this gun do not capture this vehicle. Right? Similarly, in between they drive it very fast again, and by the time they come here again they'll drive slow so that they don't get caught between these two speed guns. Yes or no? This is what people do generally. Okay, so if you have a speed gun here, then ultimately when you come close to the speed gun, then ultimately you will decrease the speed of the vehicle so that you don't get caught in the gun. Similarly, the same thing happens here. Instead of this is the technique which is followed by in general traffic police and all, but in general, rather than doing this technique, if they follow a different technique, 90% of the population get fined. Okay, you know what's the technique? I'll tell you. Look, if this is 60 kilometers per hour, and let's say the distance between these two is 3 kilometers. Let's say in a 3 kilometer gap they have put a speed gun. Okay, 2 speed guns they have put. Instead of putting these speed guns, forget about the speed gun business. Just put 2 cameras. Okay. Now let's say you track a vehicle number here. For example, let's say one vehicle is coming. So you track a vehicle number. So let's say, for example, the vehicle number is something which you have some vehicle number. Say let's say, for example, okay, I love Karnataka so much. So KA some XXGS XXXX. So let's say there is some number like this. Now, whenever you have this number, you know the classical technique. They initially check only at this point. Okay, they check the speeds at this point, and also they check the speed at this point. And if at both the points your speed is slow, they'll leave you. But instead of doing this, if they do this, let's say this is 3 kilometers, this is 60 kilometers per hour, then ultimately the minimum time you need to cross from this point A to point B, if you follow the speed limit, is 3 minutes. Correct? Means you cannot, once, let's say for example, by the time you cross this, if your time t equal to 0, then the minimum possible time that you need is to come here, if you follow the speed limit, is 3 minutes. Correct? Because the distance is 3 kilometers. But if you calculate this thing like at this point t equal to 0, and at this point x is equal to 0, and let's say x is equal to 3 kilometers at this point, and t is equal to maybe some t seconds or t minutes. Let's say for example you calculate in minutes, no issue. So let's say t minutes. If you plot distance versus time graph, okay, you will find out one thing. Average velocity you should follow in order to be within the speed limit is 1 kilometer per hour. Okay, 1 kilometer per hour. Now let's say instead of 3 minutes, you have reached this point in 2.5 minutes, for example. Okay, so let's say in reality you have reached much faster than the minimum time. 2.5 minutes is what you have done. Okay, in 2.5 minutes you have reached this point, but at both these points your speed is less than 60. Let's say, okay, at both these points your speed is less than 60, so that you have actually not fined because you didn't get caught in both of the speed guns, but you have reached from this point A to this point B at 2.5 minutes. Okay, which means definitely you might have done one thing. If you have reached this in 2.5 minutes, so this is x and this is t, of course. So if you plot this point, initially at time t equal to 0, your distance is 0. At time t equal to 2.5, your distance is 3 kilometers. So 2.5 comma 3. So these are the 2 points definitely on your traveling, because initially at time t equal to 0, let's say that's the starting point, within 2.5 minutes you reach 3 kilometers. If you connect these 2 points, okay, then slope is nothing but 3 divided by 2.5. So kilometers divided by minutes. So if you convert this 30 or 3 by 2.5, if you convert this to minutes, so 1 hour is 60 minutes. So 120 or 180 by 2.5, of course. Okay, so 180 by 2.5, roughly 75, I guess. Yeah, 72. Okay, so this is 72, which means this is 72 kilometers per hour. Means if you have definitely made these 2 points, definitely at least at one point in your trajectory, your speed is 72 kilometers per hour. Yes or no? Correct? Definitely would have traveled somewhere in between at a speed more than 60. Only because of that you have reached at something less than 3 minutes, only 2.5 minutes. Okay, if you apply this mean value theorem, because since your vehicle is satisfying these 2 points, and your vehicle has traveled obviously at every time, let's say, then ultimately at least at one point you have crossed the speed limit of 60 kilometers per hour on this limit. Yes or no? Correct? Did you get this? At least at one point between those 2 points, your speed of the vehicle is 72 kilometers per hour, 100%. At least at one point, definitely. Maybe you might have traveled at many other points also at 72 kilometers, maybe 72, then 30, 72, 30, you might have done this also, but definitely at least at one point you might have traveled at a speed which is equal to 72 kilometers per hour, which is more than 60. That means you have violated the traffic rule. Clear? But people don't use this. Luckily they use the spotting just between the speed gun. Okay, so if you don't have the speed guns, then ultimately still you can catch a lot of people, because you take the vehicle number here and you take the vehicle number here, the same vehicle, and you see the time difference between these two spots. Distance is fixed, of course. You know, let's say if I keep my cameras between say 5 kilometers down the line, then ultimately you'll look the vehicle here, and you'll also look for the same vehicle number here, and if this time difference is less than this value, then ultimately you can find the vehicle undoubtedly, okay, because you can show them the proof, which means you have crossed these 2 points within a very less time, which means you have definitely violated the speed on that road, okay. This is what, so overspeeding can be found. Understood? And velocity is nothing but rate of change of displacement. So v is equal to ds by dt, which is nothing but f dash of x at any given time. If it is as x, dx by dt, and derivative with respect to time is what you're taking, so f dash of t is what you're looking at. Clear? Did you understand this simple story? Yes or no? Did you understand what we mean by this Lagrange's mean value theorem? Clear? So basically the main idea is, at least at one point the rate of change is equal to the slope of the tangent. Okay? Fine? So is this clear to all of you? Okay? Are you all understanding this or not? Okay, fine. So what we have done, so we have done this Lagrange's mean value theorem, of course that's what we have seen. Then okay, maybe the time is up for today, only 5 minutes is left. Okay, we'll continue with the mean value theorems in tomorrow's class, no issue. But I have given you one question homework today, so please work out this question. Okay, we'll deal in maybe Monday's class. Okay, so which of the following function is continuous at x equal to 3? So this is what you have. So has anyone did this practically? No. Luckily none of them has done this. Okay, that's why all of us are safe. Many of us are safe. But if you do that, the fines will take a huge boost, the economy of the traffic. Okay, but anyway, chalo. So but not totally. See, just go through these things once again. Okay, it gives you much more clarity. Okay, and coming to tomorrow at 7 p.m. tomorrow we have the doubt revision class. Okay, so on Sunday at 7 p.m. we have the doubt revision class. Okay, doubts and revision class. Of course, you can ask all your doubts, whatever you have, maybe in the maths or whatever I have taught, or maybe in some other generalized doubts regarding GATE examination or things like some of you have asked how to balance this college and GATE exam preparation both simultaneously, or maybe college or maybe job and this GATE examination. So all these questions we'll answer in a much detailed form. Okay, so tomorrow at 7 p.m. that's on Sunday, we'll have a doubt solving. Okay, so tomorrow. So anyway, so let's quickly get into the things what we have done. So we talked about, you know, limits again. We gave a bit of introduction about the mean value theorem. Okay, LMVT, of course, Lagrange's mean value theorem is what we have done. Okay, and I have given you one question homework, of course, today. So please solve this question as your homework, and then yeah, we'll again continue on Monday, of course. Okay, and of course tomorrow also at 7 p.m. we have the doubt solving session. So please do attend without any fail. And thank you for today. You have submitted your Google form doubt, right? Yeah, it's on YouTube. Doubt class is on YouTube. Okay, it's on YouTube, the same space, the same location. So next time please add space for uploading images, as it will be easier that way. Yeah, sure. See, you can actually add images, you know. Basically if you click that, you're going to a batch. Okay, so in that batch, if you have any doubt, the slides are divided, so you can click on the particular slide and you can ask the doubt. The class was awesome. Thank you. Fine. So is each and everything clear to all of you? Okay, so if you have any doubts you can ask me, or else it's fine. We'll call it today and we'll close. Thanks for the thing hearts. Yeah, thank you all then. Okay, we'll meet tomorrow. Yeah, of course we'll meet, talk about some doubts. Okay, yeah, please Alex, please tell me. I'm always open to sessions. Okay, you can always tell me. Because ultimately the main purpose of me teaching is to transfer some knowledge, and that has to be done at the maximum possible best level. Okay, max possible efficient way. Yeah, good night. Alex has some doubt, so after that we'll clear. Okay, so rest of you can leave. Please practice as question concept wise. Yeah, that's what I've told you. Basically, I'm planning to post one document for practice on my Telegram channel very soon. Okay, so you can practice that. I'll give you questions and just answer, not the solution, but I'll just give the answer so that you can try and solve. If you cannot solve, you can discuss in the group. Okay, that's the doubt, right? Yeah, no, we'll update. So then thank you all. We'll meet tomorrow at 7 p.m. for the doubt solving session. Thank you.